product of vectors. Product of vectors. We define two kinds of products of vectors. One is known as dot product or scalar product. The other one is vector product. There are two types of products of vectors. One is dot product or scalar product. The other one is vector product. In physics, we come across vector physical quantities like force, displacement, acceleration, velocity, etc. There is a particular relation. If the force and displacement are multiplied, we get work, where force and displacement are vectors, whereas work is a scalar. Moreover, this work depends on the angle between the force and the displacement. It depends on cos theta, where theta is the angle between force and displacement. The relation for work is F s cos theta, where F is the force, s is the displacement, and theta is the angle between force and displacement. Like this, we come across some products of vector physical quantities whose product is a scalar physical quantity, and the magnitude of this scalar depends on cos theta. All such relations are represented with the scalar product. The scalar product. It is written as a dot product. If we take an example of two vectors, say p bar and q bar, if we consider two vectors p bar and q bar, then the dot product is written as p bar dot q bar, p bar dot q bar, p bar dot q bar is the dot product. There are other types of vector physical quantities. The product of two vector physical quantities is vector. The product of two vector physical quantities is also a vector. There, the product depends on sin theta. Such a relation of vector physical quantities is represented with cross product. It is written as p bar cross q bar, p bar cross q bar. We have to understand that p bar dot q bar is a scalar, p bar cross q bar is a vector. P bar cross q bar is a vector. Its magnitude is given by p q sin theta. Its magnitude is given by p q sin theta, and the direction is perpendicular to both p bar and q bar, or it is perpendicular to the plane contained by p bar and q bar. Like this, we take the direction of this perpendicular vector, cross product vector. The value of the magnitude of the scalar product is p bar dot q bar is equal to p q cos theta. The magnitude of the scalar product is p q cos theta. Imagine that the white rectangle represents a frame in the wall meant for fitting a door. Suppose the colored parallelogram represents the door. The red line represents the line passing through the hinges. We call it as axis. And the dotted line indicates a force F applied on the door. P is the point at which the force is applied. And R is the perpendicular distance of this point P from the axis of rotation. R is the perpendicular distance from the axis of rotation to the point of application of force P. Then, if we take the position vector of P as r bar and the force vector as F bar, then the torque tau bar is given by r bar cross F bar. This is how we represent the torque applied by this force. Now, I will tell you why do we express in the vector form. We know that the closing of the door depends on the magnitude of the push, that is force, the magnitude of the force applied. It also depends on the position of the point P. If P is nearer to the axis of rotation, we need more force. If P is away from the axis of rotation, we can close the door with less force. So, the closing depends on the distance of the point P from axis of rotation. It also depends on the angle between the position vector r bar and the force vector. That means you may apply a force normal to the door, perpendicular to the door, or you may push it in an inclined direction. When you push it in an inclined direction, then the force needed will be more. In inclined direction, the force needed is more. In perpendicular direction, the force needed is less. So, it depends on the angle between r bar and f bar. Moreover, the orientation of the force is expressed, the orientation or inclined direction of the force is expressed with the angle between f bar and r bar, that is theta. That is generally we indicate it with theta. And moreover, it depends on sin theta. Moreover, the magnitude of closing, the easiness of closing depends on sin theta. Now, we express this entire process, the turning of the door, with a physical quantity that is known as torque in physics. We study this closing or opening of the door with a physical quantity known as torque. We take it as a vector, and this vector is represented, its direction is taken along the red line in the upward direction, along the red line, that is the axis of rotation. It lies along the axis of rotation. It may be in the upward direction or in the downward direction. Its direction can be determined using Ampere's rule. So, we use a vector physical quantity known as torque to study the rotatory motion of the bodies. The rotatory motion of the bodies is studied with the physical quantity torque, and it is given by the relation tau bar is equal to r bar cross f bar, because the torque depends on the magnitude of r, the magnitude of f, and the sign of the angle between r and f. It depends on r, f, and sin theta. Hence, it will be expressed as the cross product. It is expressed as the cross product because it depends on the distance r, the force f, and sign of the angle between this distance and the force. R and f are vector quantities, and their product depends on sin theta. The product is also a vector quantity. Hence, it is expressed as the cross product.